Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. In today's video, we're going to talk about how to find the determinant of a 3x3 matrix. In the last video, we talked about how to do this for a 2x2 matrix, and as it turns out, a 3x3 is a lot tougher. So let's just start with an example. Let's say I have the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. And I want to find the determinant of this matrix, which means I'm swapping out my square brackets for absolute value sign looking things, which are technically not absolute values, but, looks like it. And then the question is, how am I going to do this? So there's a couple ways you can do it, but here's the way that I always do it. First, I look at this number right here in the top left position, and I'm going to say it's this number times the determinant of this mini 2x2 matrix that's not in any of the same row or column as the 1. So in other words, this is going to be 1 times the determinant of this 2x2 matrix, which I'll simplify in the next step. Then erasing these lines and starting over. Now I'm going to take this number here in the top middle position, and I'm going to find the determinant of this 2x2 matrix, again, not in the same row or column as the 2. The thing is, when I do this, I need to alternate the signs. So this is going to be minus, and then it's going to be 2 times the determinant of 4, 6, 7, 9. Hopefully you see what I'm doing. If you don't, pause the video, rewatch the last 30 seconds. But assuming this makes sense now, I'm going to erase again and do it one more time. This time with the 3, and I'm finding the determinant of this matrix in the bottom left corner. So since we alternate signs, this is back to plus, and it's going to be 3 times the determinant of 4, 5, 7, 8. And now for the rest of this problem, it's just a lot of simplifying. So watch how I do this. It's 1 times the determinant of a 2x2 matrix. If you forget, that's 5 times 9, which is 45, minus 8 times 6, which is 48. That's the first one. For the second one, it's minus 2 times 4 times 9, which is 36. Minus 7 times 6, which is 42. And then for the last one, 3 times 4 times 8, which is 32, minus 7 times 5, which is 35. So then reducing this, it's going to be 1 times negative 3, minus 2 times negative 6, plus 3 times negative 3. That simplifies to negative 3 plus 12 minus 9. And so it just so happens this equals 0. This is very much a coincidence. This almost never happens. But it's a fun example, don't you think? And so again, this is the way I do it, but maybe this is not the way you learned how to do it. So let me teach you the second method. So 1, 2, 3, 4, 5, 6, 7, 8, 9. The second method involves rewriting the first two columns like this. 1, 2, 4, 5, 7, 8. I don't rewrite this column because I don't need it. But then now what I'm going to do is I'm going to go down the down right diagonal, and it's going to be this plus this plus this. So in other words, 1 times 5 times 9 plus 2 times 6 times 7 plus 3 times 4 times 8. And then that's all going to be minus the other diagonal. So this, and this. And so in other words, minus quantity, 3 times 5 times 7, plus 1 times 6 times 8, plus 2 times 4 times 9. Technically, the order doesn't matter here for either the multiplication or the addition. So as long as you have all the numbers that I have in some order, you are good. But then simplifying this, 1 times 5 times 9 is 45, plus 2 times 6 times 7 is 84, plus 3 times 4 times 8 is 96, and then minus quantity, 3 times 5 times 7 is 105, 1 times 6 times 8 is 48, and 2 times 4 times 9 is 72. And if you plug this all in a calculator, again, we get 0, confirming that it's the same thing. So between these two methods, I don't care which method you like. As long as we get the same answer at the end of the day, I'm happy. And so now what we're going to do, we're just going to do one more example. I encourage you to try this one on your own, but I want you to find the determinant of the 3 by 3 matrix 2, 14, negative 1, 6, 5, 0, and negative 7, 3, 10. So go ahead, pause the video, use whichever method you'd like, and when you're ready to see the answer, unpause. Okay, so I'm going to assume you, as the viewer, liked the method where I rewrote the first 2 columns, and we did a lot of the diagonal multiplication, because for most of you it's easier, and so that's just how I'm going to solve this. So 2 times 5 times 10, plus 14 times 0 times negative 7, that's just going to be 0, and then negative 1 times 6 times 3. Now let me actually write that out. 2 times 5 times 10, plus 14 times 0 times negative 7, plus negative 1 times 6 times 3. And then minus these 3 diagonals. So minus the quantity, negative 1 times 5 times negative 7, plus 2 times 0 times 3, plus 14 times 6 times 10. And now it's just a matter of simplifying this. 2 times 5 times 10 is 100, plus the second one 0, because anything times 0 is 0, and then minus 18, and then minus the quantity. Negative 1 times 5 times negative 7 is positive 35, plus 2 times 0 times 3 is 0, and then plus, this is a big one, 14 times 6 times 10, which is 840. And then just simplifying this, I'm going to get 82 minus 875, and as a result, we're going to get negative 793, which is the answer to our question. That's the determinant, and we are done. So hopefully that made sense. If not, please post your questions in the comments section below. Have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.